But this is more like stuff I wish I had known like about a month or two after I started RxJava. So this is kind of a personal talk because it's just stuff that interests me. And if you've never done reactive coding before, this might kind of go over your head a bit because I'm going to assume that you've worked with it a little bit. The basis is going to be in RxJava just because that's the one that I'm most familiar with. But a lot of the ideas I'm presenting here will apply to any given reactive extension framework that you use, whether it's like Reactive Cocoa or Reactive or RxJS or .NET. All right, so this is just going to be like a collection of random things that I found interesting in reactive extensions. So the first thing is going to be composition, or using the compose method. So this, if you don't know RxJava at all, I'm going to give you like a 5-second intro to it. Typically, what RxJava is all about the observer pattern. You create observables, and that's what the observable.just is creating, and then you subscribe to them. And in between, you can put in a bunch of operators that do things. So in this case, this code lies because emitting a string is a pretty short operation, but I'm going to say that that's just going to take place of some sort of long-running network operation, say, for example. And then I'm doing 2 operators on it, subscribe on and observe on. And what these do is basically add instant concurrency to my code. And that's great. So I can say I want this long-running operation to happen on an I/O thread, and I want to observe it on the main thread, because in Android at least, if you try to manipulate your views off of the main thread, your whole app crashes. The difficulty that comes up is I might have code where I have like 15 or 20 or 30 subscriptions in it, and that's really handy, but it means I have to write those 2 lines of code 15, 20, or 30 times. And that really sucks, especially because not only does it bother me because it's duplicated code, but if I ever wanted to change any part of that, that's a lot of work for me of copying and pasting. So luckily, the people behind RxJava came up with compose, which essentially allows me, instead of having those 2 lines of codes, I can call compose and provide it a transformer. And in this case, the transformer I'm providing is actually created by a method. And the reason I have it created by a method is so that it can apply generics properly. So this is more of an RxJava specific thing, but if I don't have the generics applying properly, then it'll think that I'm always subscribing to an object instead of whatever specific type is being fed through the sequence. So this transformer is pretty simple because it basically takes an observable, applies subscribe on and observe on, and then it returns that transformer. And then this is basically exactly the same as if I had these 2 lines in line. It's just calling those 2 methods. And now I can keep applying it in a consistent manner to all of my different sequences that I create. If you have concrete types, it's pretty easy to make a transformer that you don't have to create a new object for every time. But this is a pretty beginning simple thing that I wish I'd known about more than like a month and a half ago. Because before then I was kind of baking methods and like wrapping observables, but then you would end up with this problem where you'd end up wrapping your observable.just in another method, and you lost the really cool like sequence of events sort of reading that you can do with RxJava. All right, so the second topic is lift and using custom operators. So with reactive extensions, one of the cool things about it is that there are so many built-in operators that allow you to transform the data in pretty known ways. But reactive extensions don't cover everything. There's always going to be some sort of flow that you can create that doesn't match what you are going for. So here's a contrived example. And I'm going to create interval observable. So what it's going to do is it's going to emit a number every 100 milliseconds. And then it'll print out on next, on error, on complete, depending on which events I'm getting. And in particular, what's interesting here is I'm using this take until operator. So what take until says is, if without this, it would just keep emitting forever. It just keep emitting on next until the end of time. With this take until, I'm saying I want you to emit until this other observable emits an item. And this other observable is a timer that's set to go off in 1 second. So what's actually going to happen is that it'll emit 9 numbers and then stop because of take until. Now the behavior issue that I ran into here is that what ultimately happens is it calls on next 9 times, and then it calls on complete. And that's all well and good. That's kind of like maybe what you'd be expecting. It would keep calling, and then it would finish and call on complete. But what I actually wanted in a particular case was to unsubscribe when take until kicked in. I didn't want to get on complete. I didn't want the implication to be that it actually completed normally. I wanted the implication to be that it has been unsubscribed from. So instead, I wrote this operator subscribe until, which was basically a copy and paste of the take until code that uses unsubscribe instead of onComplete. So the main difference here is that I'm calling lift instead of one of the built-in operators, and then passing it an operator object. And that pass-in operator object can do whatever I want. So this is going to be by far the most code-heavy slide of the entire talk, and I'm sorry to throw it this early on. But it's not doing particularly complicated things, except for all the generics are kind of like mind-numbing. But essentially what it's doing is it's in the constructor, it's receiving a second observable, and that's the one it's going to be monitoring in order to know when to unsubscribe. And then the real juice is what happens in the call method. And the call is past this subscriber object, which is essentially whatever the parent of the lift call was. So every single operation you have is actually just calling one after another, wrapping the subscriber, and then passing it to the next operator. And so in this case, I have, I'm just creating a parent and passing it down. So that part's pretty simple. But at the same time, I'm subscribing to the child, or not to the child, to the other observable that I want to monitor. And in that, I'm saying, if onNext is called, then unsubscribe the parent. And so, yeah, I got the behavior I wanted, and I didn't have to, there was no way to actually model that given the built-in operators. So a few caveats about custom operators. First, even though I just talked about them for the last 3 minutes, you should avoid them if possible. It's really, really hard to get operators correct. And in fact, this code back here that I showed you, like this was what take until looked like 3 or 4 months ago. I looked at it again while I was writing this talk this week, and it's like twice as long now. I think in order for them to support some really weird corner case that hadn't been anticipated with this simpler code. So it's very easy to get them wrong, and also a lot of the times the built-in operators can do what you want them to do. You might, like, one of the real challenges with reactive extensions is learning all the different operators out there. I don't even claim to know all of them. So it's just a learning process. Like one of the early operators that I wrote was this null to default operator. So nulls I tend to hate in my code because they blow up the code. I'd rather have like an empty string or an empty list to represent a lack of data. And so I wrote an operator which basically converted null sequenced items into some default. And that worked great, but there's no reason I needed to have written it as an operator. It would have been just as easy to use a map call and have the map call do that logic within it. So, like I said, if you can avoid them, I'd work on that. The other thing is really important is to make sure to obey the observable contract. And that's that onNext is called any number of times. So that can be 0, it can be infinite. And then it finishes with either one call to onError or one call to onComplete. And if you break this contract, I believe there's a little bit of protection within RxJava at least to stop you from wreaking havoc. But in general, just don't. Don't break the contract and everyone will be happy. And if you do get into this, there are tons of samples in the core library. And that's because almost all of the actual observable operators, or the built-in ones, are implemented this way. So if you go into observable.java and look at the source code, it's pretty much just calling lift and then passing in its own operator. So if you want something to model off of, go to the source code. All right, so the next topic is going to be subscriptions and how to avoid being a hoarder, or moreover, how to avoid memory leaks. And this happens a lot on Android. It may not happen as much on server code, but basically there's 2 conditions that cause memory leaks with subscriptions. And just as a quick, to back up 1 second, a subscription is what's created whenever you subscribe to an observable. So there's 2 conditions for this really happening. And the first is that your sequence has to have a reference to something. And that reference is going to leak if the sequence stays around forever. And then the second natural thing is that the sequence takes a long time to go away. It either is delayed or never ending. So if you're using like observable.interval and it never ends, and it has some long-running reference and something's holding on to that interval, then you've got a huge memory leak. And in particular, you tend to use, at least in Android, subscriptions inside of your activities or inside of your fragments. And those are pretty big, heavyweight objects. And so when you leak those, you're leaking a lot of memory. So to go through a few examples, this is a finite observable, but it does have a reference. It has a reference to this. But I wouldn't worry so much about a memory leak here because it's just going to emit 1 and call it a day. It's very quick. So that's not a big candidate for memory leaks. This one never ends. Like observable.never literally it just does nothing. It's pretty much a no-op. It's used for testing most of the time. But it has no reference to anything, so it's not really worrisome. Like you call this line of code and it'll just like do nothing, and you've wasted your own time. Here's where you start getting into things like memory leaks. And so observable.interval just keeps emitting one item every second based on the way I've written it here, and it has a reference to this. So if this sequence leaks, it's just going to run forever, and you're gonna have some memory leaks. The good news is that the solution is really simple, which is just to make sure that you unsubscribe from your subscriptions when you're done with them. It's really simple. Whenever you call .subscribe, it passes back a subscription, and then you make sure to call subscription.unsubscribe when you want to. The trick is A, knowing when you want to, and B, if you have a whole bunch of subscriptions, it can be a pain to manage all of them. Luckily, at least in RxJava, there's such an idea as a composite subscription. So it basically is a collection of subscriptions, and you can you can stuff every subscription in there and call unsubscribe, and it'll unsubscribe from all of them at once. The caveat within RxJava is that composite subscription can only be used once. So when you call unsubscribe, you can't keep adding any more subscriptions to it. You have to create a new object before you can actually use it properly again. On Android in particular, I wrote this thing called lifecycle observable, and that's actually what I was using the operator subscribe until that I just demonstrated before for, because I wanted it to say like, in Android you have this life cycle of like, the activity is created, then it's started, then it's resumed. And then opposite of that, you have pausing, and then pausing, stopping, and then destroying. And so the idea is if you created a subscription and say like on start, you probably want to unsubscribe to it and on stop. And so it actually uses a second stream, a sequence of lifecycle events in order to determine when to unsubscribe. And so that's what I use mostly in my code, is so I don't even have to worry about manually unsubscribing. I just know that it'll unsubscribe at the point in the lifecycle that makes the most sense. So next topic, let's talk about scheduling. Schedulers are this really cool thing in reactive extensions which allow you to add concurrency in a super easy manner. So you call subscribe on or observe on like I showed in the first example, and suddenly, bam, your code is concurrent. And that's great, but there are, it can be a little tricky, at least in RxJava, to use them correctly. In that, like, if you're using them properly, where you just call subscribe on and observe on once at the point where you're subscribing, it's pretty simple. But then you might write some code like this, maybe unintentionally, but what exactly is happening in this code? So I had 3 questions with this code, and I hope you don't write anything exactly like this, because it's a little weird since it's calling subscribe on twice, and it's not using observe on. The first is how many threads are spawned. The second question is what thread does just run on? What is the generation thread? And what thread is subscribe on? So what is, and that's an interesting question because there is no observe on in this case. So I'm wondering, does anyone have any guesses as to the answers of these 3 questions? There are no wrong answers, but there are actually a lot of them.
I guess there's 2 threads, just as on the current context, and what subscribe on. So the last subscribe.
So you're correct on the first answer.
Let's say the subscribe happens on the IO, because that's the last subscribe on that was called.
Yeah, so you'd think all those things. So it is true. It is true. Thank you very much for volunteering. There are 2 threads spawned. What's interesting here is that it's spawning an IO thread and it's spawning a new thread. It's not spawning a thread per item emitted, even though there's 3 different items being emitted. That's because there's no actual parallelism happening here. It's just emitting 1 item at a time, so there's no real reason for there to be multiple threads spun up. The thread that just is on turns out to be new thread, which is the first thread, the first subscribe on called. And this happens because subscribe on basically nests every call. So the first thing that happens is IO is called and it says, okay, execute all the operators above me on the IO thread. The next thing that called is, oh, new thread. Execute everything in this chain on new thread. So essentially, it's the subscribe on to IO is a no-op, except you're spawning a thread for no good reason. And then for what thread subscribes on, that actually ends up being new thread as well. So it takes whatever thread the source was on and keeps using that thread for the entire rest of the chain if you happen to never define observe on. Now, observe on is actually totally different because you can actually call observe on multiple times and it does exactly what you expect. It basically says everything beyond observe on is observed on this new thread. So you could actually have every single operator on a different thread if you want to do some really weird stuff. But in general, I would say don't do code like this. The main reason I was thinking about this was like, what if you have some sort of base observable generator that wants to define a default subscribe on? That doesn't work, so don't do that. Another thing worth knowing about schedulers is that some operators have default schedulers. So, for example, observable.interval has to run on some other thread. It would be otherwise it'll block the main thread every time it's waiting before generating the next item. So it's just worth knowing that because it means that certain operators you can be generating new threads and you won't even know it if you're not careful. So just make sure to read the documentation whenever you check out a new operator. And in particular, like operators that operate on other schedulers, you tend to be able to have a parameter that you can pass in if you want it to run on a particular scheduler. So I believe observable.interval is run on the computation scheduler by default, but you can specify anything you want. So I've been mostly talking up to this point about very concrete ideas. Now I want to go to slightly more abstract ideas. And this is hot versus cold observables. And this is a term that you might have heard before, and it's a way of kind of discussing what happens when you subscribe to an observable. So your observable is what's emitting items. The basic distinction between hot and cold, at least the way that I think of it right now, is that hot sequences produce notifications regardless of subscriptions. So basically, it's anything that's emitting items, and when you subscribe to it, the subscriber doesn't care at all. It just keeps emitting the same items as before. So like the quintessential example of that might be moving your mouse around on the screen. So if you move your mouse around on the screen, like the observable that represents those mouse movements is going to be happening if there's no subscribers. If you subscribe to it, you'll start getting those events, but it's not going to change the nature of the events that you're receiving. Yeah?
Hot and cold confused me at first. I actually screwed up in my first blog post like 9 months ago. The thing that really I think makes it simple for me is explaining it as tree falls in the forest metaphor.
Yeah, although I think that's actually wrong now, too. My old metaphor I don't like anymore. So by comparison to the hot, cold sequences are ones that produce notifications when you subscribe. So this is like basically generating data. So for me, the quintessential example of this, the one I always think of, are network calls. So when you create an observable that emits network call, like the results of a network call, that's generated by when you subscribe. I hope that the moment I create that observable, it's not going to start emitting network calls nonstop or something like that. In fact, I want the behavior to be that when I subscribe, this thing happens. Another way to look at it in a more general sense is that hot sequences have no subscription side effects. That when you subscribe to them, nothing really changes about the source observable. Whereas cold, when you subscribe, it may have a subscription side effect. The only reason I say may is because it's not like a hard and fast rule that anything has to happen when you subscribe. Like, for example, I showed observable.never before. That does nothing. So it's really not, it's hard to tell whether that's hot or cold. I guess I would say it's cold, but because it does nothing, it's kind of a moot point. So to work through some examples of what is hot versus not, let's take a look at observable.just. What do people think? Would this be a hot or cold observable? All right, so this one's cold because it generates that string every time you subscribe to it. So that's like the quintessential example for cold. By contrast, you have like the published subject, and this is the definition of like multicast items that aren't gonna wait for you at all to subscribe. It's just gonna be broadcasting to whoever happens to be subscribed at that moment. A slightly more concrete version of that is like viewObservable.clicks from the RxAndroid library. It's noticing when people click on a view somewhere on the screen. So this one would also be kind of a hot observable, but slightly more of a concrete example than published subject. Now we get into a more interesting places. What do you think our interval is? So that's the one that's emitting numbers once every particular number of milliseconds.
That's when it starts. I think it's hot.
It is cold, believe it or not. So this is very interesting. This is something I learned when writing this. If you subscribe, if you create the same source observable and you subscribe to it, wait half a second, subscribe again, it'll just be it'll generate from 1 up to infinity on both of them out of sync. So it's another generating method. So even though it's being run, you would think it's hot because it's ever running, but it's not. It's ever running, but it is generating notifications, and it doesn't start generating them until you subscribe.
And only for that subscriber.
And only for that subscriber.
Even though it's just one instance, you could have multiple subscribers, and
it acts as if there's like, multiple different instances of that observable, basically, because it creates a new base emitter on each one, basically. This one's the really confusing one, replay subject. So the way that replay works, for people who don't know, is that for anyone who subscribes, it basically gives you the items, and if you subscribe later, then it catches you up. So it gives you all the things that had happened before, and then also gives you the new items. So what do you think this is, hot or cold?
This one's cold.
Hot.
So some people refer to this as warm.
New side effects.
I think the best way to think of it, though, is that it's hot or cold depending on when you subscribe. And so it's hot if you subscribe to it. If you're the first subscriber, it's hot. And it's hot throughout the once you're done catching up. But if there's some items to replay, those are going to be generated. And so if you subscribe later on, that'll be cold when it catches you up, and then it turns hot afterwards. So weird, complicated stuff. So why should you care about all of this? Because this is kind of esoteric. The main reason for me is that operations can be expensive. So especially when you're generating notifications, like if it's a network request, that's really, really expensive. And if you want like 3 or 4 subscribers to be paying attention to one network request, you really don't want to accidentally be generating that same network request for each one of them. You want to do some sort of operation that turns your cold observable into a hot observable so it can multicast. So that's basically another way to put it, is that you don't want side effects. So with the example being network calls. Like the side effect when I subscribe to my network call observable is that it makes a network request. And that's not good. And then alternatively, sometimes you really do want side effects. And so this can happen if you have a hot observable, but you actually wanted it to be cold. And so a good example of that is retry. And the way that retry works is that if you get on error, it goes back and tries to resubscribe to the base observable again and does it all over again. So it's basically a way to it's a way to retry any operation that might fail. But if you apply retry to a hot observable, it does nothing because it resubscribes and it says, all right, I'm resubscribed. But it doesn't actually produce any new notifications as a result of that. So how do we convert between hot and cold? The main way there's a whole bunch of weird little corner cases for doing it, but these are the 3 main ways. The direct way to convert hot into cold is to use defer. And with the defer operator, it essentially says instead of starting with this hot observable, don't even create the object for the hot observable until someone subscribes. So defer is essentially a observable factory. So it says on subscribe, then you generate an observable that can be subscribed to. So now your hot observable doesn't exist until someone subscribes. You can incidentally turn things from hot to cold using anything that combines multiple observables, like merge, concat, or zip. Because if everything being fed in is hot, then the output is hot. But if any one of them is cold, that means that when you subscribe to that operator that combines multiple observables, you're going to have some side effects. So suddenly it becomes a cold observable. And going from cold to hot involves publish, which has enough intrigue to it that I'm going to talk about that more in my the next section. Yep.
Couldn't wrapping observable on a subject be a third way or a fourth way?
Yes, because all subjects are hot.
There you go.
But I don't know what you mean by wrapping it in a subject.
I guess wrapping the on next call in the subject.
Yeah, I mean, it's a little weird if you're breaking out of it, if you're basically subscribing and then having your subscriber call another on next. That's why subjects are a little weird, and I'll be talking more about them later. But yes, anything that goes into a subject becomes hot because subjects are just by definition hot. Well, except for replay subject, which is hot and cold. So maybe not always. So determining the temperature. So this becomes, now you know the dangers and why you might want to switch between them. How can you determine what temperature your observable might be? And the basic answer is you can't really do it. You can do it for limited circumstances. So for example, if you have observable.just, you know that that's a cold observable. But there's all sorts of ways that the temperature can change in ways that you might not anticipate. So if you have some sort of like normal compose operator or like any of the merge or zip or whatever, you're passing in, say, 2 generic observables, you might not know what those source observables are, so you can't deterministically figure out, like, is the output of this merge or zip or concat going to be hot or cold? Or replay subject, where it switches between hot and cold, you don't know exactly what's going to happen when you subscribe. So there are cases where you control all the code where you can determine it, but it's really kind of like a fool's errand to try to determine it all the time. So the best answer, I think, is just to assume cold, because that's where the expensive operations are. There's not so much. It's not really a big deal if you call publish on a hot observable. Like, it basically does nothing. So if you assume cold, it's best because you can save yourself from expensive operations. So let's learn about sharing, which is, so that's basically the goal here, is I want to share one network request between multiple people. Like, why share? Because cold observables generate notifications, and those notification generations can take time. So let's take a look at a not shared observable. So here I'm calling observable.create, and that's the reason is so I can explicitly call on next with a new milliseconds. And here I've got 2 subscribers. And so the output, when I happen to run this, it's very close, but they're a few milliseconds apart. And so that indicates that my subscriber method is being called 2 different instances for each subscriber. So the solution for this is to call publish. So publish creates what's known as a connectable observable, as opposed to a normal observable. And the key difference between a connectable observable and a normal one is that it generates notifications when you call connect, not when you call subscribe. And connect is a method that only exists on connectable observables. So it allows you basically to defer the point of connection to when you want it to actually start generating. So the code fixed, where you can see the output actually ended up being the same thing, has essentially I'm wrapping that original observable as a connectable observable. So these are the 2 key points here, is that I'm calling observable.publish and getting back a connectable observable. That's the one being subscribed to, and then at the end I call connect. And now I can guarantee that both of them are going to get the same generated notifications. You might think maybe it seems like kind of a pain to have to manually call connect because you're used to calling subscribe all the time. They've got your back here. You can use this method called refCount. So when you have a connectable observable, you can call refCount and it turns back into a normal observable. And the way that refCount works is that it essentially says whenever I go from 0 to 1 subscriber, then that's when I'm going to start generating notifications. But if I went from, say, 1 to 2 subscribers, I'm not going to create a new emitter for that new subscriber. I'm just going to add them on to the existing one. So in this case, this code works just fine. A shorthand for publish and refCount, if you want to use it, is share. And it basically does the same thing as those 2. So if you're really eagle-eyed and haven't fallen asleep yet, there is one line of code that's different here in this example that I snuck in without telling anyone. It's this delay thing that I put in there. And it turns out that this code doesn't work unless I stick this delay in. And this is why I'm going to tell people to be very careful with refCount, because it may not do what you expect it to do. So here's the pop quiz. When I remove delay, I start getting 2 different outputs again. Can anyone take a guess as to why that's the case?
I was gonna think that the outputs would be S1 once and then S1 again, S2, and the second 2 would be the same.
For this refCount?
Yeah, because the first subscriber tells it, well, just based on how you're explaining it to me, the first subscriber, now it says its refCount goes from 0 to 1, I'll start, and which will actually generate the first on next. The second subscriber comes in, and he'll get the next on next, I guess, but so will S1. So S1 and S2 in this case would both get the second 9931, and S1 would have only got 9925.
Well, the output there is correct for this code. So it doesn't end up doing that. What's the key thing here is that the subscriber is calling onComplete. And so what's happening is the first subscriber subscribes, it calls onNext, it prints it out, It calls onComplete, because this is all serial. It's not being run on any separate threads. And by the time that line of code, that first subscribe's done, it's already unsubscribed. So my refCount's gone from 0 to 1 and then back to 0 again. And then I get to my next line of code. Oh, look, it's gone from 0 to 1 again. I reconnect to the original observable, and I generate a new notification pattern for it. So that's why here I'm using delay. So what delay is essentially doing is it's giving my subscribers a chance to both jump in and be subscribed at exactly the same moment. And so this kind of implicitly happens with network calls, which is why share seems to work most of the time. But if it's actually instantaneous, then you run into this problem. So that's why refCount is a little bit, I don't know. I think it's really interesting, and I'm not exactly sure where I feel super comfortable using it at this point.
Can you give refCount argument like 5, 10?
Nope. In fact, I was talking about that with someone online the other day, that it'd be kind of cool if you could have a refCount that waits for a certain number of subscribers before it kicks in.
Latch or something like that, or a semi-4.
Yeah, but I mean, hey, go back to custom operators. You can, like, RxJava is open source. Go grab their refCount, modify it to have a number on it. So, all right, next topic, subjects. How to avoid subjects. So subjects are this interesting thing in RxJava or reactive extensions, which are basically like they implement both observer and observable. So they can both emit items and be the receiver of items. So it's kind of this interesting little interface that you can have, and they're hot, as we talked about earlier. And they're an easy way to kind of emit items manually for a sequence. And so like the quintessential example for this is I've got some sort of value I'm tracking in a class. And I want to say that whenever I set that value to a new value, I want to emit it as some sort of observable. But I can't just generate a string value change observable out of nowhere. So in this case, I'm creating a behavior subject, which basically represents that value at any given moment. And if you had a super reactive version of this code, you wouldn't even need to be able to store that string value. You could just have the behavior subject alone and say that anytime someone wants to get the current value of value, you'd use the observable. So why not use subjects if they're so handy? There's a lot of debate online as to like whether they're actually a good thing or not. And the main reason not to use them is because they're basically the mutable state of the functional world. So functional programming is very strict with immutability, and you get all these cool benefits out of it. And one of the cool things about reactive extensions is that it's somewhat functional in its paradigm, which gives you a little bit easier access to concurrency. So if you introduce this mutable subject, which is allowed to change at any time, you're basically mixing mutation into your concurrent software, and that becomes a lot more difficult to manage. So that's one reason to try to avoid them if possible. The other is that there often exists a simpler solution, and it tends to be like when you first start getting into reactive extensions, you learn about subjects and start trying to apply them everywhere without knowing that there are actually operators you could use to replace them instead. So there's kind of two ways that I'm suggesting that you can avoid subjects most of the time. And the first is that, if possible, just convert the data into a normal observable. So this is any case where you have like a single item or a list of items and you just want to turn that into a stream. Like that's what observable.just is for. That's what observable.from is for. And so in those cases, you don't need to create a subject just to emit data that you already have. The reason I had the behavior subject in that previous example is because I didn't have the data. It was basically a hot item, that value, because it could be changing at any time. But if you already have the data and just want to emit it, you can convert that into observable in very natural ways. And then the other thing is that pretty much every subject has an operator equivalent. And those operator equivalents might, under the hood, be using the subject, but it means that they're using it in a safe way that isn't the same mutable issues that you can run into. So in particular, async subject, what async subject does is it takes every single thing that's emitted from a sequence, waits until it completes, and then only passes on the last item it saw. It turns out that take last does exactly the same thing. Take last if you provide it 1. So that's saying look at the whole stream and only take the last thing from it. Publish subject, the equivalent of that is just calling publish. So again, you can take any normal observable sequence and turn it multicast without having to use a subject. Replay subject, this is I think the one that still uses replay subject under the hood, but you can use replay and cache as an alternative to that. And the only difference between replay and cache is that replay returns a connectable observable, and cache automatically connects. So replay is a little safer again because it doesn't have that sort of refCount thing. The problem with cache is that once you call cache, there's no way to unsubscribe. It's gonna do that base call no matter what, because it's gonna take that and cache it. And then behavior subject is just like replay subject, but it only has a buffer of one item. And it turns out that with replay and cache, you can define how large the buffer should be. So if you just define it with a buffer of 1, then you get the same behavior as behavior subject. So to make it clear, I'm not saying that subjects are evil and you should never use them. I'm just saying that if you can avoid them, why not? There's simpler alternatives out there. All right, this is the last thing. David Bowie singing with Queen, Under Pressure. So backpressure is this topic that comes up with RxJava eventually, once you've written enough of it and gotten into it enough that you are using it everywhere, and all of a sudden you start getting these backpressure exceptions. So what is backpressure? Backpressure is essentially this unevenness between the producers and the consumers in your app. So you have producers producing data, so these are the observables. You have consumers consuming data, those are the subscribers. So what happens if these things get out of whack? So you have production less than consumption or production equal to consumption. There's no real issue here. It's basically like your server is not being overloaded. But if your production is greater than consumption, then you have a problem. Because if your producer is producing 100 items a second and you can only consume it as fast as 50 items a second, you're going to run into problems eventually. Because it's just you're going to run out of memory or something. Like you don't have an infinite computer. So the quintessential example, like an easy way to cause this to happen, is to use the zip operator. So what zip does is it takes 2 observables and zips them together like a zipper. So it takes one from one from the other, zips it. Second one, zips it. Third, zips it together. So imagine now that between your 2 sources, one of the 2 sources is generating notifications twice as fast as the other one. Obviously, it has to hold on to all those notifications in order for zip to be doing the proper thing. Because then if the slower one emits, it needs to still have the queued up last item from the faster emitting one. But yeah, if you do that and you have an infinite number of emissions, then you're not going to be able to keep up. The one that emits twice as fast is going to buffer you into a backpressure exception. So that's what happens when production is greater than consumption. So there's 2 basic solutions to backpressure. And the first solution is just to produce less data, produce fewer notifications. Because this is essentially a too many notifications problem, and this is the main solution. There's a whole bunch of ways to do this. One of the ways is just to filter out data. So using something like filter, which basically says I only want to listen to certain items if they pass my test. Distinct until change basically says I don't want to emit a new item unless it's actually changed since the last one that was emitted. There's other filtration methods. I just didn't want to list all of them. You can use some sort of throttling method. So all throttle last, throttle first, and debounce all limit how many items are emitted in any given amount of time. So what the throttle first and throttle last do is they say within a given interval, only emit the first item emitted or the last item emitted. So even if there's 100 items emitted in the last second, say, it's only going to emit 1. Debounce has this really cool effect where it basically says wait until some number of milliseconds after the last item was emitted and then only emit that item. So like the quintessential example there is autocomplete. When someone's typing in, you don't want to be going to your server if they're typing in and there's only like 5 milliseconds between each keystroke. You want to wait until they're done typing before you go to the server for autocomplete. And so debounce is really good for that. Buffer doesn't get rid of any data. Like all the previous ones basically filtered out data. Buffer essentially says, okay, for any given interval, say every second, take all the items I got, package it together in a collection, and then emit it. So instead of dropping something now, you're just getting lists of items instead. And so it doesn't reduce the amount of data, but it reduces the number of items being emitted through your sequence, which helps backpressure problems. And then if all else fails, you can just start dropping notifications. So on backpressure drop, say, I'd rather the app not crash, I'd rather we just give up and don't try to use everything. Ideally, you wouldn't get to that level because it would be a lot better if you had a more sure way of controlling the data flow. But in case of all failure, this is probably what I'd recommend. They also have an on backpressure buffer, but I feel like that just like pushes the problem somewhere else. Like you can't just keep buffering forever. You're going to run out of memory at some point. So I'd rather use something that just produces less. Another answer is this thing called reactive pull. And I will be honest with you, which is that I don't fully understand reactive pull yet because it's very complicated. But the basic idea behind it is simple, which is, so say in our zip example, it'd be really cool if I could tell the observable that was producing twice as fast to just slow down a little bit and produce less quickly. And so what happens with any given subscriber is that I can actually use this request method to say, actually, I only want to request one item at a time. So I say on start is basically like when the subscriber is called, then it only requests one item. When on next is called, I deal with that item, and then I request one more. Now I will say that this has had some really weird interactions with operators because like some operators internally will have their own requests. So even though you think you're only requesting one, some operator will be like, actually, I want to request as much as I possibly can. I don't know. It's hard to work with, but it is one possible answer. A lot of the operators in RxJava implement reactive pull in one way or another. This only applies though to like cold observables. Like clearly it doesn't make sense to give a hot observable a reactive pull because if it's mouse movements, I can't just say, wait, slow down the mouse. Have the user move their mouse around less. Like that doesn't make any sense. So it only works for cold observables. It only really works on supported operators. So any operator that say introduces time, like throttle first or throttle last, that doesn't really make sense again with the way that reactive pull works. So most of the time I'd say you're just ending up producing fewer items. All right, hey, I'm gonna finish just on time. So a little bit more reading, and I'll put these slides up online so you don't have to like furiously jot these down. On some of the things that I talked about today, the first thing I talked about was using compose, and I had written a blog post that goes into a bit more detail on how exactly to use it. Subscriptions, when I was writing that part of this talk, I wanted to make sure that I wasn't talking out of my ass for that, and so I wrote a little library that kind of demonstrates how memory leaks can happen on Android. For schedulers, there is this blog post from Graham Lee, which is really neat, where he basically like went in and tested out what happens when you call these weird subscribe on, observe on things, like what threads do they actually end up on. And then there's these two great blog posts from a guy named Dave Sexton, who wrote hot versus cold and like when to use subjects or not, of which I lifted for this talk. And if you want even more details on what he's going for there, I highly recommend those two articles. So thanks for coming and listening. Thanks. And like I said, I'll post the slides up sometime either today or tomorrow. So if you follow that Twitter account or just look at it in the next day, there'll be a link there.